Hello and welcome. In this math tutorial, our task is to solve the algebraic equation on the board. Now let us look at this equation. You can see that here we have the square root of 4 plus x. Here we also have the square root of 4 plus x. Here we have the square root of 4 minus x, and here we also have the square root of 4 minus x. So the secret to solving this equation very easily is not to start by cross multiplying. No, we are going to start with a very simple substitution. So let the square root of 4 plus x, that is this, be equal to u. Of course, you know that when we square both sides of this equation, we are going to have that 4 plus x is equal to u squared. Likewise, let the square root of 4 minus x be equal to v. Once more, when we square both sides of this equation, we have that 4 minus x is equal to v squared. Of course, you know that u and v must be greater than or equal to 0 because a square root must be positive or equal to 0. Now look at these two equations. You'll see that if we add both equations, we are going to eliminate x because 4 plus 4 is equal to 8. X minus x is equal to 0. And on the right hand side, we have u squared plus v squared. Now with these two substitutions, the original equation is going to be u over 2 plus u is equal to v over 2 minus v. And of course, when we have an equation like this, you know that we can take the reciprocal of both sides of this equation. When we do that, this equation becomes 2 plus u over u is equal to 2 minus v over v. Now, at this point, let us break these two fractions apart. On the left-hand side, we have 2 over u plus u over u is equal to 2 over v minus v over v. Of course, you know that u over u is 1 and v over v is 1. So we have 2 over u plus 1 is equal to 2 over v minus 1. Now, what we are going to do is move 1 over to the left-hand side and move this over to the right-hand side. When we do that, we have 1 plus 1 is equal to 2 over v minus 2 over u. Of course, 1 plus 1 is equal to 2. And factorizing the right-hand side, we have 2 multiplied by 1 over v minus 1 over u. Now we can divide both sides of this equation by 2. When we do that, we have that 1 is equal to 1 over v minus 1 over u. The next thing we are going to do is to combine these two fractions into 1. So we have that 1 is equal to 1 times u is u minus 1, or rather v times 1 is v over v times u is u v. And finally, this is when we are going to cross multiply. This is over 1. When we cross multiply, we have that u minus v times 1 is equal to 1 times uv. Now let us call this equation 2. Let this be equation 1. Now you can see that we have reduced this system of radical equations to 2 equations which we can solve very easily. Because remember that here we have u squared plus v squared is equal to 8. But this left-hand side can be written as u minus v squared plus 2uv. Because you know that if we open up this bracket, what we are going to have is u squared 2 times u times minus v, that is minus 2uv. And then we have minus v squared, which is plus v squared. And then this, that is plus 2uv. You can see that this is going to take care of that, leaving us with u squared plus v squared, which is what we originally have. But what this simply means is that this is exactly equal to this, and this is equal to 8. Now look at equation 2. We have that u minus v is equal to uv. So when we substitute uv for u minus v in this equation, what we have is uv squared plus 2uv is equal to 8. And once you look at this equation, you'll see that this is a quadratic equation in uv. Now rearranging this equation, we have uv squared plus 2uv minus 8 is equal to 0. And we can factorize this equation. All we have to do is to find the factors of minus 8 that add up to plus 2. And of course, they are going to be 4 and minus 2. Because 4 times minus 2 is minus 8. And 4 plus minus 2 is equal to 2. So we can factorize this equation as uv plus 4 multiplied by uv minus 2 is equal to 0. Of course, you know that this statement simply means that either uv plus 4 is equal to 0, from where uv is equal to minus 4, or uv minus 2 is equal to 0, from where uv is equal to 2. So now we have two values for uv, minus 4 or plus 2. But now, let us go back to this. We know that u and v must be positive. So there is no way that the product of two positive numbers is going to be negative. So this is not acceptable. So we have that uv is equal to 2. Now, when we square both sides of this equation, we have that u squared times v squared is equal to 4. And of course, we know that this is u and this is v, and that u squared is equal to 4 plus x, while v squared is equal to 4 minus x, and this is equal to 4. But now look at this. You know that this is the difference of two squares. So this is simply equal to 4 squared minus x squared, and this is equal to 4. From here we have that 4 squared minus 4 is equal to x squared. And from here we have that x squared is equal to 4 squared is 16 minus 4. This is equal to 12. So x is equal to plus or minus the square root of 12. This is equal to plus or minus the square root of 4 times 3. This is equal to plus or minus the square root of 4 is 2 root 3. So now we have two values of x. Let us check whether both values satisfy the radical equation. Now let us substitute the first value of x, that is 2 root 3, into the equation to see whether the equation is satisfied. On the left hand side, we have square root of 4 plus 2 root 3 over 2 plus square root of 4 plus 2 root 3. And on the right hand side, we have square root of 4 minus 2 root 3 over 2 minus square root of 4 minus 2 root 3. Now, the square root of 4 plus 2 root 3 is equal to root 3 plus 1. I will link a video to where I explained how to find this at the end of this video. If I add it here, this video is going to be too long. We have 2 plus root 3 plus 1. And on the right hand side, the square root of 4 minus 2 root 3 is root 3 minus 1. We have 2 minus root 3 minus 1. Now, opening these two brackets, on the left hand side, we have root 3 plus 1 over 2 plus 1 is 3 plus root 3. And this is equal to root 3 minus 1 over 2 minus minus 1 is 2 plus 1, and that is 3 minus root 3. Now let us rationalize these two surd numbers. We are going to rationalize this by multiplying both the numerator and the denominator by the conjugate of this surd, which is 3 minus root 3. So here we have root 3 plus 1 multiplied by 3 minus root 3 divided by 3 plus root 3 multiplied by 3 minus root 3. And here we are going to rationalize this surd number by multiplying both the numerator and the denominator by the conjugate of this surd, which is 3 plus root 3. So here we have root 3 minus 1 multiplied by 3 plus root 3 over 3 minus root 3 multiplied by 3 plus root 3. Now, in the denominator, you can see that we have exactly the same thing here and here. And of course, you can see that we have 3 plus root 3 and 3 minus root 3, the difference of two squares. The product of this and this is going to be 3 squared minus root 3 squared. 3 squared is 9 and root 3 squared is 3. This is equal to 6. So here we have this over 6 and here we have this over 6. Now, when we open these two brackets, we have root 3 times 3. That is 3 root 3. Root 3 times minus root 3. That is minus 3. 1 times 3. That is 3. And 1 times minus root 3. That is minus root 3. Here we have root 3 times 3. That is 3 root 3. We have root 3 times root 3. That is plus 3. We have minus 1 times 3, that is minus 3. And we have minus 1 times root 3, that is minus root 3. Of course, this is going to take care of this, and this is going to take care of this. And we are left with 3 root 3 minus root 3 over 6 is equal to 3 root 3 minus root 3 over 6. So you can see that the left hand side is equal to the right hand side. So this value of x satisfies the original equation. Now let us substitute the second value of x into the equation. On the left hand side we have 4 minus 2 root 3 over 2 plus the square root of 4 minus 2 root 3 is equal to 4 minus minus is plus over 2 minus the square root of 4 plus 2 root 3. Of course, this is equal to root 3 minus 1 over 2 plus root 3 minus 1. This is equal to root 3 plus 1 over 2 minus root 3 plus 1. Now here we have root 3 minus 1 over 2 minus 1 is 1 plus root 3. And on the right hand side we have root 3 plus 1 over, let us open this bracket, this is 2 minus root 3 minus plus is minus 1. 2 minus 1 is 1 minus root 3. Now let us rationalize these two surd numbers. Of course, we are going to multiply both the numerator and the denominator by the conjugate of the two surd numbers, that is this and this. The conjugate of this is 1 minus root 3. So we have root 3 minus 1 multiplied by 1 minus root 3 over 1 plus root 3 multiplied by 1 minus root 3. And this is equal to root 3 plus 1 multiplied by 1 plus root 3 over 1 minus root 3 multiplied by 1 plus root 3. Now let us look at the denominators. Once more, difference of two squares. So this is going to be 1 squared minus root 3 squared. That is 1 minus 3, which is minus 2. So this is over minus 2, and this is also over minus 2. Now let us multiply the numerators. Here we have root 3 times 1, that is root 3. Root 3 times minus root 3, that is minus 3. Minus 1 times 1, minus 1. Minus 1 times minus root 3 plus root 3. Here we have root 3 times 1, that is root 3. Root 3 times root 3, that is plus 3. 1 times 1, that is 1. And 1 times root 3, that is root 3. Now here we have root 3 plus root 3, that is 2 root 3, minus 3 minus 1, that is minus 4 over minus 2. And here we have root 3 plus root 3, that is 2 root 3. 3 plus 1, that is 4 over minus 2. Obviously, you can see that this is not equal to this. So this second value of x does not satisfy the original equation. So the only value of x that satisfies this radical equation is x equal to 2 root 3. And with that, we come to the end of this tutorial. I hope you learned something new. If you enjoy such content, please subscribe to the channel. Leave us a like to support the channel. Thanks for watching and see you in the next one.